Hey guys, today I'm going to talk about simple harmonic motion. Simple harmonic motion is a type of rectilinear motion.
This model is used to model oscillations. So we'll be using this very nice line diagram along with some graphs of trigonometric equations to show you the intuitivity of this simple harmonic motion. Let's say your object starts at the origin. I don't want to say that very Hello friends, today I'm talking about simple harmonic motion. It is used to describe the motion of things when they oscillate. It is a type of rectilinear motion, means we see elements and calculations involving displacement, velocity and whatnot. We can express this mathematically using line graphs and graphs of trigonometric equations such as sines and cosines. So imagine an object that starts from the mean position. Mean position can also be the position where the object will continuously pass through as it oscillates up and down, up and down. You can actually see this here, like in the sine graph, which is beautifully depicted. So when the object goes up in the upwards motion to position A, it is moving at a velocity outwards. But when it is moving, there is actually an acceleration that is pushing it downwards, which is why when the object reaches the peak of A, this is the maximum displacement it can achieve from the mean position. So we can call this the amplitude. And at the amplitude, the velocity is equal to 0, which can also be seen in the graph here, where v equals 0 at the amplitude. When at the amplitude, the object will experience 0 velocity, as stated here. So the acceleration will actually pull it back down to the mean position and will go to v and continuously move on in the oscillation. So when the object starts in the mean position, we will use a sine graph to depict its movement since it starts in the mean position. However, if it starts at A, we can use a cosine graph, as if we start from A, the object will go down, go up, as beautifully depicted as in the cosine equation.
As you all know, acceleration is directly proportional to displacement. Given that the equation is acceleration is equals to negative k squared x. Acceleration can also be written in the form of dv dt equals to negative k squared x. dv dt can also be separated in the form of dv dx times dx dt. By simplifying dx and dx, you still get back the original equation dv dt equals to negative k squared x. dx dt can also be written in the form of v, and dv dx you just copy directly equals to negative k squared x. By integrating both v in terms of dv, negative k squared x in terms of dx, you get v squared over 2 equals to negative k squared x squared over 2 plus c. And now we're going to solve for this c. By doing so, we have to make x equals to a is the amplitude, and v equals to 0. So left hand side, 0 squared over 2, you get 0, negative k squared a squared over 2 plus c, where c is equals to k squared a squared over 2. Using back the previous equation, v squared over 2 equals to negative k squared x squared over 2 plus k squared a squared over 2, which is your c. And by simplifying the equation, we multiply both sides by 2, and you get v squared equals to negative k squared x squared plus k squared a. You can factorize the k squared out, and you get v squared equals to k squared bracket a squared minus x squared. And you take the square root of everything, then you get v equals to k squared a squared minus x squared. V, the velocity, is equals to k squared a squared minus x squared. V can be written in the form of dx dt equals to k squared a squared minus x squared. By multiplying dt to this side and dividing square root a squared minus x squared to this side, you get 1 over square root a squared minus x squared dx equals to k dt. And you integrate both. But before we do that, we have to let x equals to a sine u. And by differentiating x in terms of u, you get a cosine u. And let's make dx a subject, and you get a cosine u du. By substituting x as a sine u into the equation here, and dx as a cosine u du here. We'll get a cosine u over square root a square minus a square sine square u du equals to k dt. Okay, a square here, there are two common terms. We can factorize them out and you'll get a cosine u over a square root of a square bracket 1 minus sine square u du. And 1 minus sine square u can also be written in the form of cosine square u. And a cosine u divided by square root of a square cosine square u, you get 1. And now we integrate 1 in terms of du and integrate k in terms of dt, and you get u equals to kt plus alpha. And remember, x equals to a sine. We can simply substitute this u equals to kt plus alpha into this equation, and you get x equals to a sine kt plus alpha. This is the equation for simple harmonic motion.